We took a look at how we can import this 3D model into our scene last video. It was a video just to show you how you can import objects into your scene. Now that we have this object, it looks really cool. We have these reflections that look also very cool. We can proceed on coding. So if we open up the code editor of choice, for me it's VS Code as usual. We have some to-dos in here. So last video where we left off is we had to implement all of these. Also, I'm not preparing anything in the, in between episodes as we agreed in the comments. So we are doing everything on the fly. So where we left off is we had some to-dos. So in here we had check if the wheels, this is not necessary for now, I think. This is also not as necessary for now. And we had a last to-do, which we can set the brake calipers to rotate as we want. But also, this is not in the priorities. What I would say it is in the priority list is the camera. So we have the camera right now as a child object of this car, and it does not look particularly good. So now it's stuck in behind the car, obviously, and we cannot move it. So I would like to have some control into the camera itself. Let's take the main camera and let's not have it into the car itself. So let's have it alone like this. So in order to have some control over the camera, we are going to attach a script to it. So I'd like to stay a little organized. I'll create another folder and let's call it logic or maybe engine like this, or maybe not engine. That's not a very descriptive name. Let's name it core like this. Inside the core, I will have a mono behavior script called camera controller maybe. So now that we have the camera controller, we can access the camera controller right here. So one of the fundamental rules or maybe methods of having the camera follow anything, or in this case the player, is the transform itself. So we have a transform in here, and then we have the target transform, which is this thing. So let's go into the script and let's declare a child transform. So in here we will say public transform target like this. Now that we have the target, we want to fixed update like this. And in the fixed update, all we want to do is tell the transform that this is connected to be in this position right here. So in order to do that, we can say transform dot position is equal to target position. So this will work, but it will, snap into the target. The only way of actually progressing through and making the script actually work perfectly fine is through trial and error. So we're going to take the camera, make it a child. We have a transform. Let's give it a transform and let's hit play. So what is going to happen now is that everything is going to work the way we wrote it to work. So the child is working. We are following, as we can see, and everything is working. Now let's add a little more control into this camera. So one thing that I would definitely like to have is a offset vector. So the reason why I want a offset vector is because when I try to follow this, I don't want to snap it right in the middle of the car. I wanted to give it some, some headroom. So in order to do that, we can say public, not void, public vector3 offset like this. Now that we have the offset, all we have to do is apply that offset to the target that we are looking to snap to. So now that we have that, we can just go back and then hit play. That's all we have to do. Now we're going to see that it still snaps to, the center of the car, but now we can move the offset of where we want it to snap to. So let's leave the X for now at 0. Let's lift it up a little bit and let's bring it back like this. Okay, that's perfect. So now everything looks pretty good. And if we drive the car, we can just, it will follow. The only thing that is not properly set is the rotation. So if we, we turn our car, we're going to see that this is not the way we want it to be. Although I have to say this is very satisfying to look at. So we want this to stick behind of the vehicle at all times when we drive. Obviously, we don't want this. So in order to do that, we have to, not in here, we have to go into our script, and then we have to change this position into transform from point, like this, and inside of that we put in our vector. So after we do that, I think it should work. I'm not sure. Let's see. So if we try to do this right now, we should see that it is indeed sticking behind the vehicle at all times. Now all that's left for us to do is to use a lookat. So transform.lookat transform position. So now if I go back and hit play, we should have our car, or actually our camera, following our vehicle. That is all perfect. Okay, now that we have that, we can see that it is, snapping again, just like it would snap when we had it as a child object of the car. So let's add some kind of, rubber banding, if I may call it like that. And let's try to smooth the transition out. So the quickest and easiest way of doing that is to just use lerping. So we're going to take this away and we're going to say vector3.lerp. So this will interpolate the target transform not positioned into this time.delta time times, not times 2, but times a set smooth speed like this. There we go. Now we have the speed set to this. And as we can see, it is slowly approaching our vehicle. We can set the speed, obviously to wherever we want. And as we can see, it is working pretty well. Okay, since we have the smooth speed and we're using it only for the position, we can try to declare a new variable, and then we can try to lerp or interpolate the rotation as well. So it looks a little bit more, rewarding or realistic, or whatever you might want to call it. And to do that, we can say transform.rotation is equal to quaternion.lerp from transform.rotation into the target rotation. We always use a time because this will, obviously have this run the same way in any device, regardless of the device's power. So if we have it in a Mac, in a Windows, in a phone, this will run the same. So now we have that set up. We can comment this out, and then we can declare a public float rotation speed like this, and we can see if it actually helped. So the rotation speed is in fact working. We can set it as fast as we want, like this. But as we can see, it's not properly set. And the problem is that we are just using lerp in here. We need to use slerp. So in theory, what this will do is basically this rotation like transform lookat, but as a quaternion, so we can lerp it and we can control the speed of it. Okay, so now that we have the slerp function here, we can just go back into Unity and hit play, and let's see if it actually worked. And as we can see, it actually works. The one problem that you might have in here is that this and this have to be relatively the same. So I would suggest on just using the smooth speed for both of them. And now that we have that, we can just use this. And there we go. Now we have a very convincing setup. Before we end this video, I would like to add in a offset vector into the transform lookat position or lookat rotation, so we can have the camera look a little bit higher up than the actual car itself. So in order to do that, we are going to have to look at what this is, what type of variable it is. So we can see that this is clearly a transform rotation, which does not tell us a lot, a quaternion, blah, blah, blah. But this thing in here does. So it takes in a quaternion A and quaternion B and the smooth time. So since it takes in a quaternion, what we can do is say public quaternion and then offset rotation like this. And then in here, what we can do is times offset rotation. So in theory, this should work. Maybe, I'm not sure. Let's hit play and see what happens. Okay, so after some testing, I concluded that this W value in here has to be 1. And when we hit play, this should work normally. So it will have a lookout as it had before, but now we have a offset, which we can do, and we can set it whenever we want to look at. Maybe we want to look at it at the side a little bit. I don't know. Maybe we want to look, you know, a little barrel roll action, if you may. But the idea is that this is in fact working, and I am stuck. Okay, thank you, and we'll continue in the next video.